All right. So now I think I can start. Hello, everyone. I'm Mahdi Nouri, and this is my first ever presentation at this scale. And before starting, let me tell you a bit about myself. So I'm working at Delivery Hero as a senior software engineer in our developer experience team. And there's a high chance that you have never heard of me in the Android community. And that's mainly because I've dedicated my free time to one of my hobbies, which is photography. So yeah, a shameless plug here. If you're interested in art and or photography, you can check out my page on Instagram. All right, today I'm here to talk about extending Gradle Enterprise build scans and how my team did something cool to extend build scan reports to include even more data for build monitoring. And before that, let me give you a brief introduction about Gradle Enterprise, because I'm pretty sure that not everyone is familiar with it. So what is Gradle Enterprise? Well, before I knew anything about Gradle Enterprise, one of my first encounters with it was when I wanted to download Gradle. And for that, I would go to Gradle.com. And I would see this page. And immediately smack myself in the face because I knew I was in the wrong website. And to download Gradle, I should go to Gradle.org and not Gradle.com. Well, this wrong website is Gradle Enterprise. And it's really useful when you're working together with 50, 100, or even more people on the same project, especially from a DevX team perspective. It's really useful to get an insight about your build's performance, and it also gives you like an insight about how your builds are doing, and also it's really good for communication in your team or in your project. For example, in the cases that build isn't working in someone's machine, you can ask them to share the build scan URL with you. So you can see what went wrong with their build through build scan. And it also has remote build caching features to reduce build times, resulting in better developer experience. And it also has some other features that it's really useful. Okay, so the build scans look something like this when you first set it up. So for example, it gives you some basic information in the first glance that, for example, your build, if your build had some like issues, it failed or something, and then it will also tell you if there was like some deprecations in your build, or and also it has the console log and some other features, and basically it tells you from the start to finish how your build behaved. And it also has this feature that you can extend it. So for example, here you can see on top, now I have added CI tag and a custom link which goes to the correspondent PR for this build. And of course, this is just an example, and you can add any kind of useful data here as tags or links. There's also this custom values tab, which is empty by default. But here's also one of those places that you can attach additional data to your reports. For example, here you can see that I have added CPO model in my build scan. So whenever a Gradle task is running, we also attach this CPO model to the reports. You can also use this data to filter reports. For example, here you can see I've added a filter to just get the local build scans. This can also be CI, in the case that you want to filter out the builds and only get the CI builds. Additionally, you can use this data in the performance tab to see, for example, how your builds are performing on, for example, Intel CPUs, and perhaps compare it to the builds on Apple chips. As a wrap-up, we can extend build scans in these three forms. We can have custom tags to differentiate build environment. For example, was it a local build or a CI build? If it was CI build, was it on Bitrise or GitHub Actions? If it was on Bitrise, what was the workflow's name? And for links, some use cases are, for example, link to GitHub PR. So you have like this build scan report, and you want to see from which PR this build scan was reported. So this is really useful for that. Or the Bitrise build, or whatever CI runner that you're using. For custom values, you can put anything there, to be honest. But some use cases are, for example, CPU model, as you saw, Android Studio version, CPU temperature, CPU usage, Git branch name, and RAM usage. Later in the presentation, I will tell you a bit about like the usefulness of adding this like system information like CPU usage and CPU temperature. But of course, these are just some like examples. Okay, so yeah, so now we got like what is build scans and what how we can use them. Let's see how we can actually extend the build scans to include even more data. When you set up Gradle Enterprise in your project, you will have access to this Gradle Enterprise method in your settings.gradle file. And inside of it, you have access to build scan method. And inside of this build scan method, you have access to these three methods, which correspond to the extension features mentioned earlier. If you want to tag something, you can use the tag method. If you want to add a custom link, you use the link method. And if you want to add something in the custom values, which then will be visible in the custom values tab, you can use this value method, which receives a key and a value. One thing to note here is that you should make sure that you're passing a valid link to the link method. Otherwise, your build will fail. All right, so now that we know how to attach additional data to our build scan, you might ask where to get these kinds of data from. For example, how we would know if the environment is local or CI, or how to get GitHub PR link, or how to get CPU model. One of the ways is through system environment variables. For example, for the CI tag, you can write something like this, which checks if the CI environment variable exists or not, and then based on that passes the right string value. You can also check out the documentation for the CI runner that you're using. For example, Bitrise and GitHub Actions have a dedicated page with all the environment variables they provide. One of the useful ones from Bitrise is the link to the CI build. So you would know where that build is, where that build scan was generated. They also have this Bitrise pull request variable, which gives you the PR number. So you would know what's the corresponding PR to a build scan. They also have an environment variable called Bitrise IO, and its existence is an indicator that the build is running in Bitrise environment, and you have access to other Bitrise environment variables. This is the same for GitHub Actions, and I think it should be the same for other CI runners as well. So they all have like a dedicated environment variable that you can use as an indicator of the environment that the build is running in. To fetch system information, we can use this library called OSHI, which stands for Operating System and Hardware Information. It is open source, and you can check it on GitHub. We need this library because the way of getting system information isn't the same on all operating systems. And if you were to write this yourself, you should have different implementations for different operating systems. And that's why you can just use this library and don't reinvent the wheel yourself. And some ideas for system information, as mentioned earlier, are RAM usage, CPU temperature, CPU usage, CPU model, and operating system. The first three can be an indicator of machine's state right before starting the actual build. So if you saw a build took too long, you would know that the machine wasn't in a good state, and that might have contributed to the situation. Gradle also has an open source plugin for build scans, which adds some useful data to your build scan reports. Data such as Android Studio version, Git branch name, local or CI tags, and many more. For any kind of customization or extension on top of this plugin, they suggest to make a copy of the repository and do your customizations there. Then you can publish it internally, or you can also make it local to your project and use it directly in your project, so you don't have to publish it. Once you go for the customization route of this plugin, I would suggest you to do these three things with the plugin. First thing is that this plugin is written in Java, and if you are working in a Kotlin project, then you might as well convert it to Kotlin. Throughout the plugin, there are some checks for backward compatibility with older Gradle versions. And if you're already using versions newer than those, then you might want to remove those checks for better maintainability and readability. And last but not least, there are some code to attach data related to some tools that you might not be using. For example, if you're only using Bitrise, you might want to remove codes related to GitHub CI or Jenkins. So the strategy here would be cloning the open source repository and making it your own plugin by removing things you don't need and adding things that you absolutely need. The cost with this strategy is maintenance. So you should really see if it makes sense to customize the plugin like this. Otherwise, you can use the original plugin and be happy with it. There's also this way of maybe like forking the repository and doing your extensions on top of it. And every time maybe they release something new, you can update your own fork. There would be some like conflicts, but there's also that way. But here, I think I'm going to present this clone and own strategy. Making the plugin local to your project could be a bit challenging at first if you have never built a local Gradle plugin before. Let's say that we have created this directory in our project called build scan plugin to house this Gradle plugin. Inside the directory, make sure that you have your src directory, and this is where you will have the source code for the plugin. It has the same hierarchy as your other modules, so it's src and then main and then the package name. Also make sure that you have your build.gradle file in Groovy or Kotlin, doesn't matter. And one additional thing to have here is a settings.gradle file. Normally your modules don't have a separate settings.gradle file, but in this case we need this file because this isn't a module. This is like a separate Gradle project. In the settings.gradle file, whatever you do, don't forget to specify a project's name. This is the name of the directory. And in your build.gradle file, you need this Gradle plugin portal in the repositories block. And you also need to add Gradle Enterprise plugin as a dependency of your plugin. So you would have access to the Gradle Enterprise classes and interfaces in your plugin. And then in the same file, you can add this Gradle plugin block. And inside of it, you can add this plugin block, and then you can create or register your plugins. Just remember to pass the correct package name for your implementation class. This is the class that extends from plugin interface. Now to develop the plugin, you first need to extend it from the plugin interface with the settings type, and then override this apply function. This is the function that will automatically get called when you run a Gradle task, such as assembling the project. In this presentation, I'm not getting into the details of implementing the plugin, but if you follow the implementation from the open source project, there will be a point that you have access to the Gradle Enterprise object. And then you can write the code that you normally write in the Gradle file. For example, here we are getting build scan from Gradle Enterprise, and then calling those 3 extension functions that we saw earlier, like tag, link, and value. One additional thing, if you want to use OSHI in your plugin, you can simply add its dependency as compile only in your plugin's build.gradle file. And then for the CPO model example, you can then do it this way by constructing a system info instance and getting the information you need from it. In the same way, you can fetch other information like operating system, CPU usage, CPU temperature, and RAM usage, and all that stuff. Now that we have the plugin ready, we can go to our project's settings.gradle file. So this is the settings.gradle file for our own project and not the plugins project. And here we should make sure that we specify the correct name for our project. So in this example, it is my application. And then you want to add this plugin management block, and inside of it, include the project for our plugin. This way, we are connecting our plugin project to our main project. Now you can apply the plugin with the ID that you have previously specified for it. And just like that, we have a local Gradle plugin. And also check out the open source plugin source code and see how they are doing things when it comes to setting up the plugin. And most importantly, how they have implemented the plugin. One additional thing that I wanted to point out is that after creating your plugin, you still have this Gradle Enterprise configuration block in your settings.gradle file to set server URL and any other configuration that is needed. You can also move this configuration to the plugin itself. So when you apply your local plugin, it will also configure Gradle Enterprise for you. And of course, if you want to update something in your configuration, you can update it in your plugin. All right, so what have we learned from this presentation? We learned what are build scans and how maybe we can use them and how useful they can be. We learned the ways of extending them. For example, we have some basic data from build scans, but it is not enough for us, for our project or for our needs. We have this common custom user data grader plugin, which we can use. And even if that's not enough, or there's something in the plugin that we want to change or customize, then we can go for the route of creating our plugin, creating our own plugin, And this also comes in like different ways. The way that I've described here is clone and own. You can also fork it and do your stuff in the fork maybe, or just use the original plugin and be happy with it. Thank you for listening. If you have any questions, I think now is the time to write them so I can answer it.